Hello, this chapter talks about resistors. What is a resistor at first? It's an electrical device that resists the electric current. When an electric current enters a resistor through a resistor, the electrons of the current electric current collide with the atoms of the resistor. Due to collision, the resistor heats up and thus liberates heat. So it resists the electric current and transforms the electric energy into thermal energy that's known as heat energy. What's the resistance? The resistance is a constant characteristic of each resistor. It characterizes the resistor. It's the resistor's ability to reduce the current. Its SI unit is ohms, and its symbol is the Latin omega, as this symbol. We can measure the resistance using the ohm meter or a multimeter that functions as an ohm meter. The rheostat is a resistor actually, but actually it has a variable resistance. We can just vary this, uh, we can grab this and vary to the right or to the left, adjust it, and we can therefore adjust the resistance of the resistor. This is also the shape of a rheostat. It's also called a potentiometer. Now, the constant voltage current of a resistor. Yes. So, if we um, if we set up this circuit that consists of a battery, an ammeter, and a voltmeter, and a resistor. This is the symbol, the diagram representation of the resistor. We can draw it by a zigzag or a rectangle. After setting up this circuit, actually there is an arrow here that says that the generator, which is the battery, it has an adjustable voltage. Okay, so when we set up this experiment and vary the voltage of the battery, thus we will obtain a table including set of values between the voltages and the currents. As the voltage increases, the current will thus increase. From the table, we will draw the graph between the voltage and as the y-axis and the current as the x-axis. We will obtain such a graph, which is an increasing straight line passing through the origin. Always, when we draw the voltage against the current curve of a resistor, we will obtain an increasing straight line passing through the origin. Now, always we draw the voltage as the y-axis as the ordinate and the current as the x-axis. Mostly, we are asked to plot the graph. It's given we have the table. We just plot the points by taking a scale at first and then plotting the points, connecting all the points, reaching this straight line. Now, mathematically, this graph has an equation of y equal ax, which corresponds to an increasing straight line passing through the origin, or mainly a straight line passing through the origin. Now, mathematics says that y equal ax. In physics, y here is the voltage, U, and x is I. So, instead of y, you can write U. Instead of x, you can write I. And then A, which is the slope, it represents physically the resistance. So R is equal to the slope of this curve. So whenever we have this UI characteristic curve, it's called a characteristic curve. Whenever we have this UI characteristic curve, we can calculate the resistance by calculating the slope. And watch out here that the voltage and the current should always be in SI units, the voltage in volts and the current in amperes. So according to this equation, we reach this formula known as Ohm's law, which states that U equals R times I, the product of the resistance and the current. We simply say it's called URI. URI, U equals RI, where U is the voltage in volts, I is the current in amperes, and R it's the resistance in ohms. This is the unit of resistance. This is the first part of explaining the resistor. Please refer to the second part explaining the equivalent resistance. Bye bye.